Hello. I did go to the internet and find some practice problems. You can find this yourself on the internet by Googling this search term right here: Kuta software, permutations versus combinations. So if you want to print this yourself, you can print it from the internet, you can print it from this screen, however you want to do it. Your teacher can also help you find it. But I just went on there. This is free practice, so we're not violating any copyright laws, and want to do these problems with you just to practice our permutation and combination skills. And there are 14 of these problems, so I can't do it all in one video. I'll probably do 4 and stop and just pace it that way. But number one, we're supposed to state if each scenario involves a permutation or a combination. Now remember, with a permutation, order matters. With a combination, order does not matter. Okay, that's important to make sure you understand that with permutations, order matters. With combinations, order does not matter. All right. A team of 8 basketball players needs to choose a captain and a co-captain. Does order matter on this one? Yes. This is a permutation because it matters who is the captain and who is the co-captain. Okay. And I think I want to go ahead and just solve these as I'm doing them. So let me, because I am going to need some more room, let me try to go back a little bit on the pen size. So this first one is a permutation. And I'm going to do it both the calculator way and the long way. So to do it with a formula, you need to set up a variable box where you have permutation, n, and k. And then the formula is P of nk equals, I've forgotten it. Let me look back in the book. This is not one I use often. So we have n factorial over n minus k factorial. Okay, so in this problem, the number of players on the team is 8. The number of positions available are 2. And so we will do the math accordingly. So we have P of 8, 2 equals 8 factorial over 8 minus 2 factorial. So 8 factorial, that's going to be all clear. 8 shift 3 is 40,320 over 6 factorial is 720. And when you divide that on out, you get 4320 divided by 720 equals 56. So the number of permutations, the number of possible ways to arrange these folks is 56. Now, to do this on the calculator, I'm going to make a copy of that box. And let's put in enough of those to work with. Well, I believe it was 5. If necessary, I'll add 1. These are keystrokes on your calculator, so you'll remember the buttons that you need to press. And I'm going to make a copy of that. Let me fill it in first to be sure I have enough. So we have all clear, 8, shift, the number 1, then the 2, that's your K value, and I do need one more, equals, and I'll work it to be sure I've done it right. So we have all clear, 8, shift, 1, 2 equals 56. So that does check out to be true. So let me copy this, and I'll use it in just a minute. That is a permutation because order matters. All right, number 2. Rob and Mary are planning trips to 9 countries this year. Wow. There are 13 countries they would like to visit. They are deciding which countries to skip. Is this a combination or a permutation? Does the order matter? No. This one, as long as they get to their 9 countries, it doesn't matter which ones they do in order. So this is a combination problem. So the formula for this one will look a little different. We need to come up here and write that out. So we have the variable C, the variable P, the variable N, and the variable K. Is it K in this one? Yes. All right. So, 13 countries they would like to visit. So that's the number. They are only going to visit 9 of those. So we need to come up with the permutation, and then without drawing a tree diagram, we'll reduce the redundancy and then find the combination. And the formula looks like this. C of NK equals P of NK over K factorial. So we are going to say that C of 13,9 equals P of 13,9 over 9 factorial. So using the calculator, let's do P of 13,9. So we have all clear, 13 shift 1, 9 equals, I'm not even going to, I have to because I can't keep it in memory. This is huge. 2594 59 200. So what is that? 259,459,200 over, all clear, 9 shift 3, 362 880. So 259459,200 divided by 362,880 equals 715. So they have 715 combinations for this trip. Would you like to know how to do this on the calculator? Yes, you would, because that will save you from having to go through all that junk up there. So let me make the buttons. I believe it takes 6 on this one, but I could be wrong, so I will hold that in copy. All right, here are the keystrokes for a combination. We're going to say, did I give you the, no I didn't. Okay, so we're going to say all clear. Put in the N value, which is 13. Shift the number 2. The K value, which is 9 in this case. And then equals. And don't you love it? 715 is the answer. That is a combination because the order did not matter. All right, number 3. The batting order for 7 players on a 12-person team. Does the order matter? Yes. And so this is a permutation. I'm going to put the longhand right here. I probably need to bring these over to some notebook paper before we get down into the bottom. So we have P, N, and K on this one. The batting order for 7 players, so the order that matters is 7 positions on a 12-person team. And so we are looking at the permutation of 12, 7. So we have 12, it's not squared, factorial, over 12 minus 7 factorial. So we have 12 factorial. That's going to be ginormous. 47, 900, 1600 over 5 factorial. That one's getting to be familiar, 120. So you have 47,900,1600 divided by 120. And that cannot be right. Can it? 399,1680. Let's see. I'm going to do it on my calculator. I'm not going to draw all those again, though. I'm just going to copy this down. That doesn't feel right, but it sure may be. So let's see what we've got. So I need to take out the 8 and the 2 and put in the 12 and the 7. So all clear. 12 shift 1 7 equals, it sure is, 3,991,680 different possibilities. Heavens to Betsy, that's a big old number. All right, number 4, and then I'm going to stop this video. There are 45 applicants for 3 computer program positions. Are the positions ranked? Is there a gold position, a silver position, and a bronze position? No, they're just 3 open positions, like the 3 seats on that shuttle. So this is a combination. And I'm going to put this in maybe right here. Because remember, this one needs an extra variable. We have C, P, N, and K. So we have 45 applicants, but only 3 of them will be chosen. So our formula, let's do the calculator first just to see what we're looking for. Because I don't like that feeling of panic when I think I've missed it. It's been a very long time since I've done these. So let's put in the values for this problem. We have a 45 in the N slot and a 3 in the K slot. So all clear. 45 shift 2, 3 equals 14,190. So let's see if we can get the math to work out. So combination of 45 and 3 is going to equal the permutation of 45 and 3. And then when you take out the redundancies, you will have 3 factorial. So on your calculator, do the permutation. All clear. 45 shift 1, 3 equals 85140, and then 3 shift 3 is 6, and then 85140 divided by 6 is the number I want to see. So there are 14,190 combinations for that value. And if you want to go back and fill in these variables, I think that's a very good practice. I'm just short on space, but you definitely can do that and have all of that information in an organized space. All right, my friends, I'm going to stop this video. I will come back with you and we'll finish these problems up.